right, so we've got an evaporative cooling process, and this is essentially the exact same problem as problem 3.7b, except for 3.7b we were actually given some extra information to allow us to pinpoint state 2 on the psychrometric chart. But in this case, what we're going to note is that it's an evaporative cooling process, and so for an evaporative cooling process, we can make the assumption that the wet bulb temperature is approximately constant. So we're supposed to find the relative humidity at 1 and 2, and then we're also supposed to find m.w over m.a. So the rate at which liquid water is sprayed into the airstream in kilograms of water per kilogram of dry air. So that's the m.w over m.a. So if we go to our psychrometric charts, which we can use because we're at 1 atm, I see that my wet bulb temperature is 25 degrees Celsius, and you can see the wet bulb temperature. You can see on the curved line, the one that represents 100% relative humidity, you've got 0, 10, 20, and 30. So just go to the line in between 20 and 30, and that's 25 degrees Celsius for your wet bulb temperature, and then your dry bulb temperature is on your x-axis, and that's 55 degrees. And you can go ahead and pull off your relative humidity, which was one of the things that you were supposed to find. And I'm pulling off my specific humidity because that's actually something I'm going to need in just a hot second. And then I am going to recognize that this is an evaporative cooling process, and as such, my wet bulb temperature is approximately constant. So now I'm just going to draw a line along that wet bulb temperature of 25 degrees Celsius to where it intersects with the dry bulb temperature of 40 degrees Celsius, and I'm going to go ahead and pull off the relative humidity, which is what I need to get anyway. And then my specific humidity, and the reason that I'm getting this is because if I apply my conservation of mass, and if you've forgotten how we get this, go ahead and watch the humidification video. I can get an equation for m.w over m.a. So it's just the conservation of mass applied to the control volume, as you see here. So let's see. Yeah, conservation of mass applied to the water portion, actually. All right, well, I hope that was helpful. Thank you so much for watching.